Like I feel like we have maybe not. I can just like.
Okay. So question number 5 and 9 on the exit ticket you guys did are the type of problems that we're going to do today. Where we're going to kind of work backwards. We're going to have an area, and we're going to use that to find a z-score, and then we're going to use the z-score to calculate or transform it into an x value for our data set. Okay. So first, we're going to practice just finding the areas and the z-scores that go with them in our purple packet. So grab that. Okay, so remember the purple packet, your z-score chart only gives you cumulative area or area to the left. So for the first problem, I think you guys have a little thing there. There we go. We are looking for a z-score that goes with a cumulative area of 0.3632. So as soon as it says cumulative area or less than or area to the left, it's just the number that you're finding. So we're looking in the middle where there's two sides of your chart. If you are on the left side of your mean, it's a negative z-score or your area is less than 0.5. If you're on the right side of your mean, you have a positive z-score or your area is bigger than 0.5. So here I have an area that's smaller than 0.5, so I know I'm going to look at the negative side of my z-score chart. And then we're just looking in the middle to search out this 0.3632 number. So if you can find that number, then we're going to look to the left and we're going to look above, and then that's the z-score that goes with that cumulative area. So for this first one, the z-score that we're looking for is negative 0.35, and that would be the answer to this question. Okay. If it gives you something to the right, so either area to the right, or in this case, a percent of the distribution to the right, you have to adjust that number first like we did before you can look it up on your chart. We need to find area to the left. So if 10.75% is to the left, to the right, I need to figure out what's to the left. We're just going to do 1 minus that. If you write it as a decimal, it's 0.1075. And then we subtract. So is that 0.8925? Is that right? Okay, and then that's the number that we're going to find. Now that's a bigger number than 0.5, so I'm going to look at the positive side of my z-score chart. And I'm going to look in the middle for 0.8925. And let's see. Double check me on these. My eyes are old, older than yours. 1.24 it looks like is my z-score. Okay. All right. Sometimes it'll give you an area between, and you need to find the z-scores that are on the ends of that shaded region. So here we have 95% of the distribution in between two z-scores, and because it's symmetric, the z-scores will be opposites, one positive, one negative. I think it's helpful to sketch these ones. So if 95%, like that, is in the middle, what percent is left over to be in the tails of that curve? 5%, okay, and then because it's symmetric, we can just split it in half and say we've got 2.5% of the data down here and 2.5% of the data up here. I'm going to use the one on the left. That's going to give me the negative z-score. If I look up 2.5% or cumulative area 0.0250, if I write that as a decimal. And then if I want the positive z-score, all I have to do is change the sign. So it's really going to be plus or minus whatever I locate in my packet here. So if you look up 0.0250, we get negative 1.96. So the z-scores I'm looking for are plus and minus 1.96. If you look up positive 1.96, the cumulative area is 0.9750, which means 97.5% of the data is to the left, which makes sense with this picture. Okay, any questions on any of that? All right, if you're given a percentile, which that's what these notations represent. Remember percentile from chapter 2, I think is when we did these, means percent below. which as far as our z-scores are concerned, it means area to the left, that percent to the left. So if I see P sub 5, I know 5% of the data is to the left, so the cumulative area I'm looking up is 0.05. And let's see here. It's going to be my negatives. Okay, so if you look at your chart, 0.05 is not an exact number on here. It kind of hovers between two things. If I look at a z-score of negative 1.65, I have an area of 0.0495. If I look at a z-score of negative 1.64, I have an area of 0.0505, okay? And 0.05 is the midpoint of those two. It's right between them, okay? So what we do is we just take those two z-scores, if we're right in the middle of them, add them up, divide by 2, find the midpoint, negative 1.645 is the number that we're going to use then. Any questions where we're getting these numbers from? Everybody kind of seeing it in your purple packet? Okay, so 0.05 is in the middle, and then I look to the left and above. Okay, when I see the 50th percentile, that's probably one that you don't need to look up. If you're at the 50th percentile, where are you in the bell curve? In the middle. So what's the z-score in the middle? 0. You can look up 0.5 if you want to, but it's 0. Okay, and then the last one we're going to do is the 90th percentile. Thank you. Okay. All right, so 90th percentile, we're going to look on our chart for 90% as a decimal, so 0.9000. Okay, and that's going to be on the positive side of my z-score chart because it's bigger than 0.5. Okay, and it looks like it's between two numbers again. So if I look at a z-score of 1.28, I have 0.8997. If I look at a z-score of 1.29, I have an area of 0.9015. So I'm definitely between those, but 0.9 is not a midpoint of those two numbers. It's closer to one than the other. So we just choose the one that it is closer to, if that's the case. It's closer to 0.8997 than 0.9015. Okay. Any questions on those? Okay. So now the next slide, once we can locate that z-score, we can use a formula to transform the z-score into the context of the data that we're looking at. This formula is your z-score formula. We already know it. I'm going to take this formula and solve for x because that's what we're going to be trying to find. So what we're going to do, we're going to multiply by the standard deviation first to get it out of the denominator. So it'll be z sigma equals x minus mu. And then I'm going to add the mean to both sides. So it'll end up being z times my standard deviation plus my mean equals x. Okay, so it's the same formula. We're just manipulating our variables a little bit to get something else alone. But if you have z and you're given your standard deviation and your mean, you can use that to interpret that in context of whatever data you have. So we'll just do one of these problems at the bottom so you can see what this looks like, and I'll practice a couple more in the next few slides. A veterinarian records the weights of cats treated at a clinic. The weights are normally distributed with a mean of 9 pounds and a standard deviation of 2 pounds. Find the weight x corresponding to a z-score. Interpret the results. Okay, so the first z-score they give us is 1.96. We don't have to find it in our chart. It's already given to us. So we're just plugging it in the formula. 1.96 times my standard deviation, which is 2, plus my mean, which is 9. All right, so 1.96 times 2 plus 9, 12.92, and then this represents weight of a cat. So I'm going to label it pounds. Okay. And then if I were going to interpret that, I would say a cat, 2 standard deviations, about 2 standard deviations from the mean, weighs 12.92 pounds, or you could say almost 13 pounds. Okay. All right, we won't do the next two because they're the same sort of thing. Just plug them in and it's the same interpretation. Okay, so let's try this one. Many investors choose mutual funds as a way to invest in the stock market. The mean annual rate of return for large growth mutual funds during a recent 5-year period was about 12.1% with a standard deviation of 1.8%. Between what two values does the middle 90% of the data lie? All right, so 90% of the data is in the shaded region. So what percent of the data is left over for the tails? 10% total. So what percent's in each tail? 5%, 5%. And we're going to be finding two z values. There's going to be a negative z value on the left and a positive z value on the right. And those two z values then we're going to convert to an x once we find them. I'm going to, again, use the one on the left because that's what my chart gives me. So I'm going to look for a cumulative area of 5% is what's on the left side there. So 0.0500. And this is one that we already looked up already. It was between two numbers. It was right in the middle of two numbers. We had a z-score of negative 1.645. Okay, so the z-scores that we're going to use are a positive and negative 1.645. So on your chart, if you look at negative 1.64, negative 1.65, falls right between those two. All right, so now I'm going to convert both of them to x's. So I'm going to take my z, I'll start with the negative one, negative 1.645, and then we're just going to use the standard deviation and the mean that's given to us. Standard deviation is 1.8, mean is 12.1, and then you're going to do the same thing for the positive z value. Okay, so negative 1.645 times 1.8 plus 12.1. For the top, I'm going to get 9.139, and these are rates of return, so I'm going to put percent there. 1.645 times 1.8 plus 12.1. This one's going to give me 15.061%. And if you look at where the ends of those shaded regions are, on the left and the right there, you can see about 9% and about 15% are reasonable for the picture that we're seeing here. So you can kind of visually check that that makes sense. So I would say that the middle 90% of returns is between these two values. The interpretation of that, if I needed to do that. Okay. Any questions? All right, flip your paper over. Let's try this one. Scores for the California Peace Officer Standards and Training Tests are normally distributed with a mean of 50 and a standard deviation of 10. An agency will only hire applicants with scores in the top 10%. What is the lowest score an applicant can earn and still be eligible to be hired by the agency? Okay, I'm going to draw my little curve here. We want to be in the top 10%. Okay, so we know that's going to be to the right. And we are trying to find the lowest score that will place me in the top 10%, which is pretty much the z value that starts that shaded region. Okay, that's going to help me get that x. What cumulative area am I going to look up on my chart to help me figure out that z value? If 10% is to the left or to the right, what percent is to the left? 90, right? So we can do 1 minus 10% or 1 minus 0.1, and we're going to get 0.9000 is to the left of that score, and that's what we can find. All right, so I'm going to look on the positive side of my chart. 0.9 is what I'm trying to get close to. All right, we're between two values. Which one am I closest to? 1.28 is the z-score that we're going to use. Once you have the z-score, you can convert it to an x. So 1.28 times the standard deviation here was 10, plus the mean is 50. So a score of 62.8 or higher on the test would put you in the top 10%. Everybody seeing these numbers okay? I know they're kind of small. It's kind of hard to follow along with that.
So.
Mm-hmm. So that was 90%. So percentiles are always percent below. This one was a percent above. So we had that extra step of the 1. Yeah. Okay. What score would an applicant earn if they were in the bottom 5%? So you can use the same picture. Bottom 5% is over here. Now, because it's the bottom 5%, we can just use a cumulative area of 0.05. And again, that's that same z-score we found a couple times already. You're going to notice there's a lot of the same like significant values that we use over and over again, these common percentages, 5, 10, 15. And then we just plug it in. So my x will equal negative 1.645 times 10 plus 50, which will be 33.55. So a score of 33.55 or lower would place you in the bottom 5%. Questions on those two? Okay. Last slide we're going to do together is this guy. High levels of cholesterol in blood increase the risk of heart disease for 14-year-old boys. The distribution of blood cholesterol is approximately normal with a mean of 170 and a standard deviation of 30 milligrams per deciliter. The X is the cholesterol level of a randomly selected 14-year-old boy. Okay, first question. Cholesterol levels are above 240, and those, or if they are above 240, require medical attention. We're going to find and interpret this. Okay, so the probability that X is greater than 240. This is not new to this section. This is a review question. If we're finding a probability, we have an X. The next step is to find the Z. The Z gives us the probability. Remember, that was that procedure, right? X to Z to the probability, or we can work backwards. Probability to Z to X. We can go either way. All right, so first thing I'm going to do is convert my X into a Z. So that would be 240, my X value, minus my mean in this problem is 170, divided by the standard deviation of 30. So that's 70 over 30, or 7/3, or 2.33 would be that decimal. Okay, so now the probability question I can write in terms of a Z. I'm trying to find the probability that my Z value is greater than 2.33. If it's greater, what am I going to have to do? Complement? 1 minus whatever I find on my chart. All right, so we're just looking up 2.33. Find 2.3 on the left column. Go over to 3 on the top. Looks like 0.9901. So I get 0.0099, or if I wanted to find that percent, it'd be about 1% if I move that decimal 2 spaces to the right. So interpreting that, we could say about 1% of, I guess, 14-year-old boys need medical attention for cholesterol. Those are the scores that are above 240. Number 2, people with cholesterol levels between 200 and 240 are considerable risk for heart disease. What percent of boys are between 200 and 240? Okay, so 240 we already converted to a z-score. 200 we did not convert to a z-score, so we'll do that real quick. 200 minus 170 over 30 is just going to give me 30 over 30. It's going to give me a 1. Okay, so in this question we are finding the probability that I have a z-score between 1 and 2.33. The 1 comes from the 200, the 2.33 comes from the 240. If we are finding a probability between, it's just bigger minus smaller. The bigger area comes from the 2.33. We did that a minute ago. It was 0.9901 minus We need to find the cumulative area for the smaller one, which is 1.00, so 0.8413. And then we subtract. And I get 14.88, and they wanted a percent, well, 0.1488. Let me write it that way first. And they wanted a percent, so 14.88% is the answer that we're looking for on that one. All right, so those two are just review from the last couple sections. The last one is what came from this section now. What cholesterol level would place a 14-year-old boy at the 10th percentile? So if you know you're in the 10th percentile, that means 10% is located which direction? To the left. 10% is always to the left, or anytime it's a percentile, it's percent to the left. So because that's percent to the left, you can just look up 10% or cumulative area 0.10 on your chart to get the z-score that goes with it. Okay, so we have this probability, we have this area, we find the z next. 0.1, I think the closest I can get to that is 0.1003. So that would be a z-score of negative 1.28. And then we convert that into an x value. So negative 1.28 times my standard deviation 30 plus my mean 170. Negative 1.28 times 30 plus 170 gives me 131.6. This is a cholesterol level, and they're labeling it milligrams per deciliter. Okay. So that kind of puts both topics all in one problem. I like that one. Questions on any of those? Okay, the last two slides are yours to try, and what I'm going to do is I'm going to put these on the board together. I think I can put them up as like a dual display. There we go. All right, I want you guys to try these with your partner or somebody near you, and then I'll call 6 groups to put answers up on the board. Let's round everything to 2 decimal places for this, okay? So all 6 problems have to do with that bell curve you see for braking distances, stopping distances. All right, I'll give you a couple minutes. We'll put them on the board, and then we're done for today.